All right, let's take a look at equivalent expressions and determining when they are equal. It could be that they are always equal, sometimes equal, or never equal, and that's what we're trying to figure out. So here's a typical problem. 7 minus x, is that equal to, question mark, x minus 7? So you have to figure out if that's always, sometimes, or never true. And so the hint down here is try some different numbers to see what you can figure out. So if you just play around with numbers, you're going to start to figure out which numbers follow mathematical patterns and which ones don't. So it is sometimes true, and that only occurs when x equals 7. Because if we go back to this original problem and we play around with some, I would say some very important popular number choices that you should be working with are numbers like 0, 1, and 2, possibly 3. Like by then you should know if things are working or not. So if I plugged in 0, I would have 7 minus 0, which is 7. On the other side, I have 0 minus 7, but that's negative 7. Those are not equal. So 0 doesn't work. If I did 1, I would have 7 minus 1. Does that equal 1 minus 7? Well, that gives me 6. This gives me negative 6. This is not working. Eventually, you can see that that's not working. And so then you figure out that it only works when x equals 7. Therefore, it's sometimes true, even though it's just one value. Okay, how about this? What if we're looking at something like x plus y? When does that equal 2x? Well, there's not a lot of things that you add together that make double the first thing unless those things are the same, because you end up doubling it. So let's take a look. So the answer is they are sometimes true when x equals y. So if they're the same, 0 plus 0, as you can see, is the same thing as 2 times 0. 1 plus 1, 7 plus 7 are the same thing as doubling all of those. So when the x value equals the y value, we say that they're true. It's definitely not always, because as soon as you put in different numbers up here, so if I go up here and I put in a different number, like I put in a 3 here and I put a 4 here, that makes 7. Well, 2 times 3 is 6, because that's the x value. Those are not equal, so that does not work. Okay, what about something where you get n's in the numerator and n's in the denominator? So we have n's right here in the numerator, n's right here in the denominator. Now what happens? Well, we know this is a proportion, so we should be thinking about cross multiply. When you cross multiply, you get n squared equals negative 9. Well, to solve a squared, we do a square root. So if I do a square root of n squared, I get n, which is okay, but then I can't take the square root of negative 9. Therefore, you end up with a negative under the square root, so there is no solution or no real solution. All right, how about this one? This one has an x squared minus 1 divided by x minus 1, and then you got this x plus 1. You're trying to figure out if this is equal. Well, I'm going to tell you right now, we got to watch out for the fact whenever you have letters in the denominator, bad things can happen, and you'll see that in the very last slide of this video. So we got to watch out for that. So what I would do is I would start by factoring, because I know that x squared minus 1 is the difference of squares, so that's x plus 1 times x minus 1. And then on the bottom, I already had the x minus 1, so those are going to cancel. That's what's happening here. Those basically turn into a big 1, and then I end up with x plus 1. So wouldn't I end up having on this whole side, which is this front side right here, that's going to be x plus 1, and then the back side was x plus 1, so isn't x plus 1 equal x plus 1? People think, oh man, Mr. Cater, that's got to be always true. Well, that's not always true, because of the part that you have to watch out for, and that is when you have an x or a variable in the denominator down here, you can end up getting, in the bottom, you could end up putting 1 in for x, and you'd have 1 minus 1, and you'd get divided by 0. I'm sorry, but if you take any number, even like 5 divided by 0, 10 divided by 0, that's impossible, because you can't have 5 items and then divide them. I can't have 5 things right here and then divide it into 0 equal groups. That doesn't make any sense. So you can't divide by 0, and doing that in math is a major problem, so we don't do that. Okay, so then in looking at, it's not true when x equals 1. Therefore, that is my sometimes statement. So it's sometimes true when x can't be positive 1, because you would have a divide by 0. Okay, and then in this one, some people are wondering about this. I've got this, the 3x plus 3y, and then you've got x plus y. Does that just equal 3? Whoa, whoa, whoa. This is division. Division doesn't reduce addition. So there's no reducing you can do here. You've got to be very careful. You can take out a 3 and then do some reducing, so we can do that, but you can't just cross these out yet. That doesn't work. So what you have to do is you have to take this original form and then factor out a 3, because of distributed property I could put those back in. So you have x plus y and x plus y. Those reduce and make a 1, or we say that those cancel, and I get 3 equals 3. I'm thinking, wow, I got another one that's always true, because that's a true statement. But you got to be aware of anytime you have variables in the denominator down here, we've got variables, that means we could end up trying to divide by 0, and that would be bad. So it's not true when any combination of x plus y makes 0, then we would get that divide by 0 error that we want to stay away from. So it looks like it's always true, but you have to watch out if there's variables in the bottom, in the denominator. All right, let's take a look at this one. This one is a situation where we have 10 times a times b. Does that equal 10 times b times a? Well, one of the things that you start to learn is that the commutative property is always true in multiplication. So it's always true because no matter what numbers I put in here, even if I reverse the order, multiplication doesn't matter. And so therefore, it's always true. This one, is this always, sometimes, or never? Well, if I took 3 times a plus 2 times b, when does it equal 5 times ab? Well, if you think about that, it's going to be sometimes true, because this is where I told you earlier that you should be looking to test 0s, 1s, and 2s. 0, 1, 2, and possibly 3 to really get a handle on what's going on. Because if you go up here and you test in some 1s, well then these are 1s, and then it's 3 plus 2 is 5, and then these would be 1s, that would be 5. So you can see here that the 1s work. Well, 0s would also work because they zeroed out. 1s and 0s behave differently than any other numbers in math. That's why you have to check those. And then you also have to check something that's not a 0 or a 1. Okay, so here, if you look first glance, I've got a cube a number plus another number cubed. If I add those together, can I also just cube them? Well, you got to think about that a little bit, because it's only sometimes true, and that is when it's all zeros. Otherwise, if you plug in any other numbers, you get big number here plus big number here, and that does not equal adding those numbers together and then taking it to the third power and cubing it. Finally, as a summary, I want you to watch out for variables in the denominator, as you could end up with a divide by 0 error, which is very bad. Test numbers that are easy to work with. You always pretty much have to test 0, 1, and 2 to see how it behaves. 3 will help you kind of see exactly what's happening. If you have 2 variables in the problem, you should think about having them both be 0, one of them being 0 and the other being 1, and vice versa, and then both of them being 1, and see what happens. Those 4 combinations right there are really easy and quick to do mathematically, and they will tell you a lot about the problem. And then lastly, try some random different numbers and see what happens. And then if you happen to divide by 0, this is what could happen, and we don't want that. That's a very bad day.